Okay. Good morning, guys.
Good morning.
Good morning, sir.
Okay, very good
Good morning.
morning. Okay. So, any doubts so far in the previous day session, yesterday session, regarding the plant simulation
No, sir.
definition and basics? I hope you are thorough, right? It's clear.
Yes.
Then we will be jumping into next one. Okay. So now, can anyone tell me what exactly is a plant simulation? I have given you a number of definitions, out of which one definition I have made separate. What exactly the definition of plant simulation?
Plant simulation is virtual testing.
Okay, virtual testing. See, any definition we can't say with a simple word. So, virtual testing for what purpose? That you need to conclude. Then only it would be a definition.
The plant simulation is a process in which we create the plant virtually and test it by optimizing the resources.
Okay. See, same thing. You have explained the process. For what purpose we are doing that? That you are forgetting. For what purpose we are doing all these simulations or by using this software?
So, for visualizing and optimizing production systems, the flow of materials and logistic operations.
Yes, correct. But still you have missed one thing. Last thing. See, all these simulation softwares we are working for
Optimizing
Setting up
efficiency.
an industry.
Increasing efficiency.
increasing the efficiency. So whatever the process you are.
Setting up an industry.
Hmm. See, okay, fine. Now, plant simulation is a software where we are creating and simulating the process for increasing the plant efficiency. That is what exactly the simple definition is. So, whatever the thing you want to add, you can add, but at the end, for what purpose we are doing this? For increasing the plant simulation, for increasing the plant efficiency. That you need to add. Then only it will be a perfect definition. Okay. Now, coming into the procedure. So before starting the plant simulation or after having a complete idea, which we have discussed in this slide, like a planning, manufacturing project, every now all the this data is available with me. Now how to start the simulation? So there will be a certain procedure to follow that one. First one is describing the model. Now what exactly describing a model is? Let me on the pen. Yes, which means now I want to create a layout for helmet manufacturing, or I want to create a layout for ceiling fan, okay, for fan manufacturing. For that, so I need to make sure that what are the different things I need to have, how much layout I am having. So the layout dimensions, how much machineries I am having, how much capital should I am having. So with the capital I am having, so what are the type of machineries I can purchase, what is the land I can procure. So like all the things I need to make sure. That is what exactly describing a model. Describing is a model nothing but, so what exactly I'm going to manufacture at the end of the day. For manufacturing that particular part, for X part, so what is the type of layout I am going to use. So what type of area that need to be required for that preparing the layout, how many number of missions will be needed, all the data that will is required should be supposed in this one. That is called as a describing model, documenting all the things. Documentation for the plant which we are going to manufacture is nothing but a describing a model. Just like the PLM, in PLM what is having, we will be having some idea or innovation. That I phase is nothing but describing the model here. Okay. Next one is a planning phase. Planning phase nothing but, now I have all the data with me, all the related, data related with that plant. Now how I need to start, where I need to start. For starting, so what will be the first model I need to have. So what is the first process? Now this is the process running. In between there is an error. Now what will be the alternative method? So that is what exactly the planning phase is. So if this is the plant, so initially I want to start the plant A, I mean process A. There is a, this plant is having A, B, C and D. A is the first process and D is the final process. Now out of these four, which I need to start? So if at all I start the B, then what will be happen? It is not correct. So I need to start with A. Then once I need to, I have prepared the model A. Then I need to check it. Once it was running perfectly, then I need to go for the B. Then I start preparing the B. Same with the C, same with the D. This is how exactly the planning phase will be. So if at all I starts with A, so now what are the things I need to consider for starting A? So what are the different parameters I need to check? These are called as a supposed to be considered in the planning phase. Now I have the model, now I have the planning phase, now the data collection. Data collection is nothing but, let me just a second. This is the plant, okay? This is the plant, and this plant is having 9 different processes. Each and every process is having certain number of missions, certain number of inputs. 1, 2, 3, 4, 5, 6, 7, 8 and 9. The plant is having 9 different processes. Each and every process is having some input, at the same time some output. This output will supposed to enter here and some other process is happening. So this is simultaneous. This is what exactly happened in this plant. Now I need to collect the data for this one, which means in the first process, how many missions will be having? So there will be having 20 missionaries. Now I need to collect the complete information regarding that, all the missions in this process, which means there are 20 missions. So what are the 20 missions? What are the specifications of 20 missions? What are the limitations? When the, what will be the drawbacks? What will the failure state? How much time it will be needed? How much cost it will be needed? What are the different type of resources that will be needed for this process one? So how many number of humans will be involved for running this process? What will be the continuous input? How much input rate that I need to produce, that I need to give to this process to get it maximum optimized? Like all the data that's regarding in the plant that need to be collected, that is called as a data collection. Each and everything. If at all I am using some conveyor between these two stations, now what is the length of conveyor? What type of conveyor I need to use? Whether I need to use a belt conveyor or a roller conveyor or some tube conveyor, different type of conveyors. What type of conveyor I need to use? So if at all I'm using a belt conveyor, what type of belt I'm going to use? If there is whether this conveyor need to work continuously 24/7 or it going to work with some sort of PLC, some respective sensors, how I need to operate it? So if at all I'm using sensor, what is the program that I need to use? So how much power it is consuming? So what are the type of resources? If at all there is a failure, where exactly the failure need to be in this conveyor? Like all the things related to the conveyor that need to be there collected. So like in the plant, the plant is having 9 different processes. All the processes data need to be collected. That is called as a data collection. Now I am having a model with me. Now I have some sort of plan. Now I have collected complete data. Now the planning phase is done. Now I need to start here. This is called as a creating a simple model. So which means, like I already told you, every process starts with a single model only. So if this plant is having 9 different processes, now I need to start with process 1. So this is my process 1. Here I am going to start with a simple model, like first mission and second mission. I have mapped this one. This is the starting process. Now there is having 20 missions in this process one. Now I have done 2 of them, then 3, 4, 5, 6. Like I need to create a model for this 20 with the 20 missions. Now I have prepared a layout for this process 1. Now I need to check whether this layout is perfect or not. So if at all I use a straight layout like this, 20 missions are placed in this direction. So how much place it will be constraining? Now I don't want like this. Now I want to do modification. Instead of plus one, I want to go for a circular one. This closed loop. So what will be happen if I use a closed loop? What will be happen if I use a C section? What will be happen if I use some sort of different layouts? Like I need to check for that model. That is called as a creating a simple model. So now I have done the first one. Then I need to go for 2, 3. Like I need to create a simple complete model, basic model for all the 9 processes. Once the 9 processes model was finalized, then I need to check whether this process will be completely mapping with my location or not. I mean with my layout or not. So my layout is having this much of space, and together all the 9 process it will be coming to this much of space. It is not acceptable. Now I need to utilize this place and I want to constrain these process in itself in this direction only, in this area only. So now again I want to do some modifications till I will place these missions in this one till I need to do the modifications. This is what exactly creating a simulation model. Okay, once I have created the model, which means once I have fixed these 9 processes in this complete layout in the in the prescribed path. Now I am having 9, 1, 2, 3, so on 9 in the layout. Now this was finalized. Now this layout is somewhat acceptable. Now I need to verify the model. Verifying the model is nothing but, so I have created the model. Now I need to check the model, I means how exactly it is running. So I want to check with respect to 1 day, 2 day, 1 hour, 2 hours, like I need to check the plant model. So whether it is running perfectly or not, there will be having any delays or not. Now I need to check. Now I need to give input to the first process, and automatically by giving the first process I need to run the simulation for 1 hour or 2 hours. So after 2 hours I need to check. So I have given material to the first process at starting of 00. Now after 2 hours, where exactly the material will be? Material is at fifth station or sixth station, I need to consider. So this is what exactly verifying is. Verifying is nothing but checking. Now I need to check. So I have given material to the first station input, and now I want to collect the output. So I have given 100 number of pieces to the process 1. Now I am waiting for 100 number of output after process 9. So I have collected 100 number of outputs. So I have stopped the, I mean, I have paused the simulation. I have checked the time, how much time it will be taken. So let us take some 5 hours. So for manufacturing or for producing 100 number of parts, it will be taking 5 hours. So this is what exactly verifying is. Now after verifying, now I need to add some failures in it. So if at all I want to add some failures, till now this process running without any failure. Now I need to add some failures, some losses, like human efforts. There is a loss in the material movement, there will be loss in the logistics. Like I need to add all those things, and again I need to check. Now instead of 5 hours, I'll be getting some 6 hours or 7 hours because of the actual characteristics also. So this 6 hours is the maximum characteristics final. I have produced 100 number of parts after 6 hours with considering the failures and all the losses involved in the plant. So this is called as a verifying the model. Now I want to check this model for 1 week. So what will be happen if I run the model for 1 week, and I want to check how many parts that will be produced. These all conditions come in the verifying phase. Okay. Now after 1 week I will be getting some 6,000 parts like this. Let us assume. Then okay, this is the throughput for a week for the complete plant. So this is what exactly the verifying model is. Now what will be the validating? Any idea on this word validating?
So to approve the model.
Approve the product. Okay, fine. In the software, validating is completely different. Validating is nothing but, see, I have prepared this model. Let me erase all these things. I have prepared this model. Okay, and in this model, for preparing 100 number of parts, it will be taking 6 hours. 6 hours for 100 parts for 6 hours. This is the final output, realistic output. This is I have received the information from the verifying the model. Now I want to validate the model. Validating the model is nothing but I want to check this model at what condition this model is going to fail. I mean, at what condition this process A will fail, or B will fail, or C will fail. All this eighth state is going to fail. I need to check. Which means if at all I run the plant for 6 hours, there is no any static failure or dynamic failure. If at all I run the plant for complete 30 days, after 30 days, where exactly the failure will come? If the plant is not going to fail at any condition after 30 days also, still I need to check. I need to check for 130 days. I need to check for 230 days. Maybe at some extent, what will be happen? Maybe at some 300 days, because of continuous running, this B second mission is second process is going to fail, or the seventh process is going to fail, or the first process itself is going to fail. Like I will be getting some results. That is called as a validating. Validating is nothing but checking the maximum extent. At what extent this process is going to fail? At what extent I am getting the maximum efficiency? What will be the last production? At what time I will be getting the maximum production? At what conditions I will be getting the production? After what extent this process is going to fail? Collecting all these data is nothing but validating. So at 300th day, maybe process 2 is going to fail. Process 2 is going to fail is nothing but process failed. So 300 is the maximum. So I have given some documentation, I have collected some data, and I have recorded it, which means this plant is going to run for maximum of 280 days. Maximum of 280 days. Beyond that, what will be happen? This process start going to fail. Like I will be giving some information to the production team, so that what will be happen, they will going to run this model up to 280 days. After that they are going to stop the model, they are going to maintain this complete process, and again they are starting with this day one. This is how exactly the process will going to decide, the process going to manufacture in the industry. This is called as a validating. So now I have the complete model, I have checked it for, maybe I want to run this plant only for 30 days, for every 30 days I want to do maintenance, then there is no problem. Why? Because this plant is going to fail at 300th day. Now I am preparing the plant for 30 days, for every 30 days I am running the plant, and for the every 31st day I am doing some maintenance work for the complete process, and again I will be starting from the day, I mean day one, from the next day. So this process is not going to fail. This is how exactly I have verifying data, I have some validating data also. Now the plant is till extent it was running perfectly. Now I need to executing and collecting the results. This is nothing but this one, which means what is my what am I supposed to do here? I want to run the plant for 30 days, I want to run the plant for 30 days, and after 30 days I will be maintaining the complete process for one day, and again I will be continuing repeating the same process, which means 30 is the maximum continuous repetitions. After 30 there will be having one maintenance day, again it will be starting again 30, so 30 is the maximum. So at 30 days, at this tenure, what will be the results? That is what exactly this executing and collecting the results is. So at 30 days what will be the production, so what will be the expecting production from this virtual model? So let us assume some after 30 days there will be having some 7,000 parts. So this is the estimation, and for every 30 days there will be having 30 gigawatts of power usage, and there will be having some 30 humans that is involved, and there will be having some material resources, all the statistic data I need to collect in this one. That is called as this one. Okay, in this one, executing and collecting the results. I want to check the model for 30 days, and I need to collect the complete data for this one. This is executing the results. Now finally analyzing the results. Analyzing the results is nothing but here there are two different cases. Case one is newer plant. If it is a new plant, and second is a existing plant. If existing, first I will explain you this existing. If it is existing plant, then what will be happened after 30 days? In virtual I am getting 7,000 parts, whereas in actual I am getting only 6,500 parts. Now I want to do this analysis part. Why? Where exactly the lag will be there? Now I need to cross verify. So after 30 days from this mission there will be having 7,000 parts. Now I need to verify this with actual model. In actual model also there will be having 7,000, then it was okay. Here also it was okay, here also it was okay. Like I need to check it in each and every process. At this phase what will be happen? Instead of 7,000 this will be producing only 6,800 parts. So now there will be having a loss of 200 here. After that in this process there will be having 6,750, there will be having some 50 parts loss will be there, and here there will be having 6,700 parts, which means what will be happen, there will be a process, I mean delayed in these things. Now I need to check why exactly the process delayed. Now I want to enter into the process 4 in detail. So why exactly this was happened, how much time it will be taking for each and every process. Now I need to do this one. This is called as a analysis, analyzing the results with actual as well as existing, if it is a existing one. If it is a newer one, then I need to verify it with the models. In theoretical, there will be having some theoretical calculations also. In theoretical, I have defined for every mission there will be having 2 minutes of processing time, and my plant is having 100 missions. Now, a part is entering here, and there will be having hundred missions in the plant. For every operation, there will be having 2 minutes of processing time. Now, how much time it will be taking to collect the output, theoretical output? Clear? See, there is an input that is entering into the plant, okay, and there are 100 number of missions, and time t is nothing but 2 minutes. For every operation there will be having 2 minutes of time. Now what is the expected I mean time for this part to come out? 100 minutes, 100 missions, each mission is having 2 minutes, which means theoretically we will be having 200 minutes. This is mission processing time. Now the station is having some material handling. For every material handling there will be having 1 minute, station to station. Now plus 100, so together I am expecting a part after 300 minutes. This is what exactly theoretical value is. Theoretical, I mean with respect to theoretical, this is what exactly the part I am supposed to expecting. In actual what happened, I mean in this model I am having 350, I am getting the part after 350 minutes. Why there is a 50 minutes delay? what exactly happened, why exactly this 50 minutes happened, so where exactly the process is lagging, so what made this 50 minutes increase. So I need to check that one. That is called as analyzing the results. Okay. After analyzing the results, then this one, final result charts for model simulation, which means if at all you want to present all this data, how exactly you are going to show. So there will be having some charts in the plant simulation software with which you are going to describe. So this is my actual model and this is my virtual model. And if it is a mission characteristics I'm talking about, in this mission characteristics, out of 80% mission usage was there, 80% green is there, and 5% of failure is there, and 15% of bottleneck is there. I need to describe the model with respect to the graphs so that it will be easily understandable to the person who are going to verify it. That is called as the final result area. So this is how exactly we are going to start the simulation or the procedure of simulation, or we are going to submit the model to any superiors. If a project is received, then this is how exactly we are going to follow. So if a project was received for the plant simulation team, then first of all they will be reviewing that what exactly the model will be, what they are going to produce. Now after the collecting data, then they are going to plan. So with the data collected, how exactly I am going to start the model, what are the different phases. Okay, that is second step. In the third phase, for each and every phase, what is the mission, so what will the mission data, what will be the complete resource data, that I need to collect the data. Once I'm having these three datas with me, then I need to start creating the model with respect to simple things. Once I have created the model, then I need to check the model, so and its behavior at the given time, at the given conditions. 30 days is the maximum given condition. So at the one day what will be happen, 2 days what will be happen, at 30th day what will be happen, I need to check the model. So once I am having the once I have verified the model also, then I need to check the model for validation. At what extent the model which they have prepared will going to fail. That data they also collected, and after that they are going to collect the data, collect the records, and they need to do some analysis part. Once the analysis will be done, then they are going to represent it with some sort of pictorials or some sort of data, which means documentation, and they have to hand over it to the next project team or the NPI team. NPI team is nothing but new product introduction team, or NPD, new product development team, so that they will start the model. This is what exactly the procedure of the simulation is. Clear?
Yes, sir.
Everyone clear? So that we will go into the next slide. Otherwise, I will explain you if you are having any doubt. Fine.
So analyzing is only for older plants? Is this true? Means,
No.
or I am understanding?
Analyzing is not for older. It is for newer as well as a new, both. If it is for new as well as existing. If it is a new, then what will be happen? They are going to analyze it with theoretical results. There will be having some theoretical behind it. So according to theoretical, what will be the result? But in actual, what is the result? That we need to do the analysis part here. In existing, we will be comparing with the actual plant. That is analyzing is.
Okay, sir.
Now, okay, uses of simulation. So what type of uses we are going to, I mean, if at all I'm using this plant simulation software, then what are the different type of things I am going to achieve. That is what exactly we are going to discuss in this slide. First one, if it is a new facility, like I told you, there will be, this simulation is for new facility as well as for existing one. If it is a new facility, then determine and optimize the times as well as throughputs, which means I can calculate for each and every process what will be the throughput. There will be having some 10 missions at any type of condition I can check. So the third mission, what will be the throughput of third mission? At some 40th, 47th mission, what will be the throughput at some 500th minute? I can check at continuous manner. That is one of the main advantages of this software. Second one is determine the dimensioning. Dimensioning nothing but the layout modeling. So I have created the layout here, but I have created the layout in this respective. But the actual plant layout is this much. Now how I want to scale it, how I want to reduce this one, that can also be possible in this dimension, which means I can directly create a plant with this large scale, and if the plant is having some limited resources, limited layout resources, then I can scale this model to 1 is to 2 or 1 is to 3, like that, so that I can fix the model here. This is one of the key facility in the plant simulation. Directly we can use the scaling factor, and with the scaling factor we can reduce the the layout dimensionings directly. So that what will be happen? So in this large layout, I have followed some condition. For every mission to mission, there will be having some 1 meter apart. I have created like this. But in actual, this is the layout. If I scale this down 1 is to 3, then what will be happen? Based upon this, it will maintain here. So here 1 is to 1 meter apart. Here there will be having some 350 meters apart or 400 meters apart. Automatically scaling will be happened in this one. So if the length of the conveyor is having some 7 meters here, here in this when it comes to scaling model, then what will be happen? Based upon that, 7 by 3 will be happen automatically. The length will be calculated and dimensioning with respect to that one. That is the dimensioning. Third one is determine the limits and performances. This is called as validating. So how exactly, what will be the maximum limit, at what condition the machine behavior? If there is a CNC machine is there, the CNC machine is having some 1000 inputs continuously. So what is its behavior after 1000 outputs? So what is its failure rate? So how exactly it is going to fail after 1 hour or 2 hour, after 1 day or 2 days? That I am going to check the performance of the machine. That is this one. Next, investigate the influence of failure, which means uh, just a second. 1 2 3 4 missions are there. I am running this plant without any failure. Okay, now what, this was done, this was done, this was done, and this one failures. Now what will be happen if I add a failure to this mission? Each and every mission is having its own failure. No any two missions will be having some common failures. This is CNC, 4 CNC missions, and this mission is having some 5% of failure for every 3 hours. This mission is having some 10% of failure for every 5 hours. This machine is having some 2 percentage for every 5 hours. This machine is having some 20 percentage of failure for every 10 hours. Now each and every machine will be having its own failure rates. So with that failure rate, how exactly it will define our product and define our process? So what is the impact of this one? What is the influence of this failure in this process? Now it's a continuous running, running process. There is a continuous input like 10,000 or continuous input is there. Now in this continuous input, what is its impact? If there is a sudden failure is there, because of the sudden failure, what will be happened? Will there be any alternative mission? If there empty, see, all these missions will be having mttr 2 minutes. Mean time to repair is only 2 minutes. So which there is no need of alternative missions. Why? Because 2 minutes is a lesser time when compared to hours. So there won't be any alternative missions here at this condition, which means the mission need to wait for the mission to be repaired. So for the two missions, this mission is going to wait. So what will be happen in the two missions? Then after two missions, again the parts will be producing this one. Now what will happen if these two missions simultaneously failed? What will be happen if these two missions will be simultaneously failed? What will be happen if this mission as well as this mission is failed simultaneously? Like there will be having n number of permutations and combinations with which I am going to check what will be the behavior. So at what time I am going to produce, I am going to get 10,000 parts. Like this is what exactly the influence of failures will be. That also we can check by using this software. So initially we are going to create the complete model without involving any failures. If my plant is having 100 CNC missions, I can create 100 CNC missions like this, and I am going to run it. After running it perfectly, then I am going to add failures to this mission. Now I will check. So why? Because the layout is fixed. Now based upon the layout, I will create the model. Now I need to define the failures. Now after defining the failures, so what is its impact? How exactly it will be behaving? Now I need to check that one. That is influence of failures. Next one is determine manpower requirements. I hope there is no need of explaining this one. Manpower. If there will be having 100 CNC missions, do I need 100 humans, or do I need only 50 humans? How exactly it will be defined? That also we can map by using this software, which means for every mission there will be having 1 hour of processing time, or a 2 hours of processing time, or some 5 minutes of processing time. Now, so what will be happen if there is a 5 minutes of processing time? What will be happen if there is a 1 hour of processing time? We can check that also. If it is a 1 hour, I will try to give assign one human, and I'll check what exactly happened with this failure. So I will try to check if it is a 2 minutes of processing time, I will assign one human or two humans, and I will try to check the complete model. So if it is having one human, whether the process is running perfectly, or will there be any delay? I will check that also. With the two humans I can check, with three humans I can check. Like I can check the model continuously with how much manpower is also required. That can also be collected with this simulation software. Gain knowledge on about the behavior of the facility. This is nothing but the validation. So which means if at all I'm creating this model, I'm having an idea when exactly this model is going to fail. What will be the maximum condition at which the machine, this process is going to fail? I need to have some idea, which means I need to know the behavior of the facility. So if there is a continuous input 10,000 or 20,000 input, then what will be the mission behavior? So if there will be having only 100 missions, 100 parts, now what is the mission behavior? How exactly I am going to map that one? That can also be, we can calculate by using this type of software. Next one is determine suitable control strategies. These control strategies I will explain you when I show you the software. Why? Because okay, I will give you a glimpse. There are three missions, okay, and there are two missions here, and there are four missions here. One, two, three, four. This is A, B, C, and this is X, Y. Now A, B, C is producing 100, same 100, 100 parts to XY. Now how many parts this XY will going to produce? Hmm?
300.
Yes, this machine is having 300 load. Now, this X and Y will be connected with four different missions, one, two, three, four. Each and every mission will be having different capabilities. This mission is having a CNC, multi CNC, which is a multi high-end mission. This mission is having capability of producing 100 parts. So I am giving 100 parts to this. Out of 300, I have given 100 here. This mission is a somewhat older CNC mission. This mission is capable of only 50 parts. This mission I am going to give some 70 parts. Now this is the rest R. Now what is happened here? It is not equally distributed. This is called as a control strategy. So how I am going to distribute the material to each and every station? So how I need to define what is the condition I need to adapt if at all I want to follow these type of things. This mission is having a, I mean, it's a new mission, so it is having lot of efficiency is there, so I need to produce 100 number of parts from this one, whereas this machine is having some limited scope, so I'm giving 50, same 70 at the same time rest. So here there will be a, what will be happen, it is a different things. If I haven't given any strategy here, then what will be happen, automatically these 300 will be divided, equal divided to 4, which means every machine will be having 300 by fourth part. So all four missions will be equally divided. Now by using this strategy, what will be happen, I can change this one, I can monitor this one, I can control this one. This is called as a strategies. Even this also, if 100 missions are coming here, 100 missions are coming here, 100 missions are coming here, this mission can control this one. This axis need to receive only 100, whereas y can receive 200. That can also be possible with these strategies. This is called as a strategies, controlling the operations or monitoring the operations or upgrading the operations, nothing but the strategies. I will explain you these things while showing you software. Okay. Next one is evaluate the different alternatives. Like I already told you. So if this mission was failed, what will be the condition? This is the crucial in this process. Now this mission X is failed. Now what will be the alternative? Do I need to have some alternative mission? If the mission is apart, if the mission is having some 10 meters apart from this complete station, how the material movement will be happening to this station? Do I need to use a conveyor, or do I need to use some instant AGV so that the material is picking here and it will be dispatching here? After that, from this station again I need to follow the same condition, and I need to distribute the material to the subsequent stations. This is called as alternatives. Again same, we need to use some control strategies here. At the same time we can follow some alternatives. These are the some of the usages. I mean, not the maximum usage, these are the some of the usages if it is a new facility. Now, if it is an existing facility, then automatically we can optimize control strategies. That is what exactly defined here. If the plant is utilizing something, like I already told you, equal number, with the equal number I am not achieving the maximum efficiencies, then I can use the control strategies. CS. I can use the control strategies. With the control strategy, what will be happen? Maybe I'll try to increase the plant productivity. I can do that also. See, one, two, three, four different lines. After first line, there will be having 100 missions. Okay, and after second mission there will be having only 20 missions, and after third there will be having 30 missions, and after fourth there will be having 4 missions. Now there is a input that is coming here. The input is 300. Now how I need to do give the input? Do I need to give the input equally, or do I need to use some strategies here at this condition? Hmm? See, there is a input to the plant. The plant input is 300. and there are four missions. Those four missions are individual missions. Those four missions, after processing, they need to dispatch the material to the subsequent stations. After first mission, there will be having P1. The P1 is having 100 missions. P2 is having 20 missions. P3 is having 30 missions. P4 is having 44 missions involved in it. Now, how I need to distribute the input to these missions? Do I need to distribute equally like 300 by 4, or do I need to add any control strategies here?
Control strategies.
Why? Because
Which has strategies.
strategies. Why? Because see, after first there will be having 100 emissions that are waiting for the part, which means it is having more rate of production, more rapid production is there. So I need to give continuous production to this. What will be happen, so that don't any mission will be kept idle. So whenever a part is coming, it will be entering into one of the missions. So there will be having 100 missions, so that I can, the part will be going like this. I can give some 100 inputs to this one, and I can add some 50, 30, and the least to this fourth mission. Why? Because after this there will be having limited number of missions. So based on which I can manage the production. This is called as a control strategies. I can have optimize the control strategies if it is an existing plant, and I can showcase it to the industrial people. This is what exactly I will be getting if at all I use some strategy. I have modified the plan. Like I need to showcase it to the industrial people. If they are acceptable, if they are accepting that one, they can go with the production. They can improvise the production. If they are not accepting, anyhow, we need to go for 3 by 4, 300 by 4 only. Second one is optimize the sequence of orders. Same. If it is like this, if this is the input, and input is giving parts to these four missions. Now it is following some sort of orders, which means first part will be giving to the fourth mission. Second part will be giving to third station. Third part will be giving to second station, and first part will next part is giving to the first. If it is following in reverse order, what will be happen? These 100 missions will be in waiting phase. So one more condition: if I am giving continuous 10 parts to this first station, after that 2 parts to this one, and 3 parts to this one, and 1 part to this one, again I am giving 10 parts to this one. If at all I want to follow this type of sequence order, that is also possible with this plant simulation. What is happened with this one? So whenever a part is produced continuously, it will be giving some few parts to this one, so that the next mission is going to produce, there will be having some, I mean, parts in the conveyor. No worries. Why? Because this in the meantime, this will be given to this one. It is giving, producing two parts. One is with the mission and one is in the conveyor. In the meantime, this mission is giving parts to this third mission. One part is with the mission and two parts on the conveyor. Same with the last mission. It is giving only one part to this one. So what will be happen? One part is processing here. Again it will be coming here, and again it will be dispatching 10 parts. So that what will be happen? So this process is not going to fail. Why? Because there will be having no, a large number of missions. Like I need to optimize the orders also. I can increase the sequence of orders. I can change the orders also. That is what exactly sequence of orders is. Test the daily proceedings. This is called as a validating or verifying. So at the, for every 1 hour, how this process is behaving, I can check it. For every 8 hours, for every shift, how the process is behaving. For every day, how the material is behaving, how much output I am getting, what is the throughput of each and every mission. I can calculate all those things with this, if it is existing plan. Okay. Now, with by using the simulation, we can definitely increase the profitability of the facility. In that, what are the type things we are going to increase? Like a throughput is nothing but every mission occupancy. Now here there will be having 100 missions, out of which only 50 is utilizing up to its mark, and 50 is not utilizing, which means 50 missions is having two throughput, and 50 missions is having one throughput, which is not acceptable. So if at all there is this thing, then all the missions need to be having two throughput, then it is a perfect missioning. Then I can monitor that also. I can increase that throughput efficiency, resource utilization. So I can do the resource utilization also by using this one. Utilization of the facility, better utilization of the facility. With this software, we can increase the buffer sizes. Buffer, okay. This word I will explain you when I show you the software. Okay. Next, number of transporters as well as AGVs. These are called as a material handling devices. Logistics. Number of workpiece carriers. Production schedules and sequences. This is a production schedule. How exactly I am going to schedule this one? So what type of sequence it need to follow for this set of these things, I can determine by using this one. And with this simulation, at the same time, we can decrease some also throughput times, required resources, storage requirements, validating design process planning, identify bottlenecks, reduce WIP, evaluate capital investments, optimize control strategies, avoid planning errors. Okay. When I show you the software, I will explain you all these things in detail, like what is a bottleneck, what exactly we will be, so what will be the planning processes, what is the investment, capital investment, if at all I am creating this type of plant, so what is the investment I need to have, how much power resource I need to utilize, all the things I can check by using these things. Optimize control strategies, like strategies, if at all I want to follow some set of strategies, what type of strategies suitable for the particular process. I can't use all the strategies in a single process. For the process defined, so what type of strategies fixed, what type of strategy will be beneficial, that can also I can check by using these type of softwares. Avoid planning errors. So like I told you, so if this is a sequence, so instead of the material moving completely like this, so what will be the alternative, what will be the easy, if at all I will be creating the model like this, layout like this, what will be happen, so any errors will be raised or not, that I can check by using these type of softwares. Okay. This is,
Sir,
yes.
सर थ्रूपुट नंबर ऑफ ऑक्यूपेंसी है कि नंबर जो ऐसे सब समझा दीजिए प्लीज कि मान लीजिए एक मशीनिंग हो रही है, एक चीज nth नंबर हो रहा है मशीनिंग, तो वो n जो मशीन हो चुकी है उनको भी काउंट करना है कि जो nth है उसी को हम थ्रूपुट कहते हैं कंप्लीट.
Just a second, I will explain you by showing you the software so that it is easy for you to understand. Give me a second. The software is opening. Is it visible?
Yes, sir.
Now just have a look. Okay. Now is it visible? Here see, there is a
Yes,
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 sir.
sir.
there is a three here, throughput 0, which means this drain is not having any part, and this machine is also not having any part, whereas this machine is having one entry. Okay, this entry is nothing but throughput. Now I will show you. I will run the simulation. Okay, or in simple I'll explain you one more thing. That's the throughput. See, now throughput is nothing but mission occupancy. Throughput, throughput, throughput. Even the drain, see, one is a throughput. Now I can check the statistics also directly by entering into this one. And total throughput is how much? Now if I increase this plant simulation, see speed. Now the drain throughput is 31. See, total throughput is 31. Clear? Which means what exactly throughput is now? Now you explain me. Mission occupancy or the capacity of the mission at that point of time is nothing but throughput. Okay. This mission
Yes.
this mission throughput is 34. Why? Because it is having 33 parts processed and 34th part is processing. This mission is having 33 throughput, which means 33rd part is processing. This mission is at 32 throughput, which means 32nd part is processing here. The drain is having 31 throughput, which means it is having 31 parts involved in it. That is called as a total throughput. Okay.
Yes, sir.
सर तो वो जो 50 और 2 वाला आप बता रहे थे वो थोड़ा क्लियर नहीं हुआ था उसमें कि मतलब कैसे 2 थ्रू
Okay, fine. Now is it clear, everyone?
Yes, sir.
Okay, fine. No any problems. I will explain you all these things while showing the software. So at that time, what will be happen? It will be much more easier for you. Okay. Now I will explain you all those things later when time comes. Now this one, concepts, and till now we have discussed about what happened. Okay, till now we discussed about what exactly a simulation is, simulation capabilities, and how to start a simulation. If at all I want to run the simulation, then what are the things I need to consider with the simulation, what I am going to achieve, all the things we have discussed. Now I am going to explain you in this session. Okay, before that, yes, have we covered these things? Have a check on these things. So definition of simulation, have we covered?
Yes, sir.
Uses,
Yes,
Yes,
sir.
sir.
basics of plant simulation,
Yes, sir.
where and why we are going to use simulation. Next one is starting of simulation. So I hope we have covered each and every point in this session. Now I will be explaining you the next thing, that is called as concepts and features of simulation, in which we are going to consider, or we are going to revise on the concepts, on what basis we are going to use this simulation, and what are the various features of the simulation. Simulation is capable of what are the different things, that also we can discuss in today's session, in this session. Okay, like in this session we are going to discuss about changes, basics of plant simulation, where and why, and features of plant simulation again. Okay, I hope you are thorough with this one, right? Pillars of industry.
Yes, sir.
Yes, sir.
On the day itself I have explained you all these things we are going to use in the plant simulation. See, that is what exactly it is. Creating this complete cycle virtually is known as a plant simulation. In the simulation, if at all I am going to start an industry, then I am going to use a raw material as an input, missions for the thing processing, as well as some sort of process for the parts, for the things I need to convert from raw material to output. At the same time, I need to check the time with respect to cost, as well as how many humans will be involved for doing the process. All these things we are going to involve in the plant simulation. Any doubts? Okay.
No, sir.
Now, One of the key thing. So industry changes, what exactly industry changes means? Now you tell me what exactly, like we have discussed in the day one as well as day two, evolution of missions. Okay, in that how the missions will be changing, how the process improvising, how the efficiency going to increase by using this evolution. Now here in this presentation we are going to discuss about industry changing, how the industry is going to change, or what is the need of industry to be changed. Now you tell me what exactly industry change means.
Adopt new technologies.
Adopt new technologies. Okay, fine. With adopting of new technologies, what I am going to what industry is going to benefited?
So the marketplace is always evolving, and there is a need for new technologies and new equipment so that your industry is up to date with the standards of the world.
Yes, there are a lot of things that need to be considered for industry changing. Out of these are the key essential things that will drive the industry to be changed. First one is speed of market. Now what exactly a speed of market would be? If you have produced a circular phone, or basic example, this is a rectangular phone, this is in the market. If at all I am going to produce the same rectangular phone, a phone in the market, then what will be happen? There will be having huge competition in the market. Now instead of which I am going to produce a phone that is called a circular phone, b. Now if I design this model, manufacture this model, I am entering into the market. Now what will be happened? Will my demand is high or not? If at all I'm meeting the customers,
Yes, sir, the demand will be high.
the demand will be high. So what will be happen? The part which you are prepared here, this is having a lot of impact in the market. So I mean the demand will be more, and there will be having lot of things I need to produce. So initially I have produced only 1,000 components as a test piece, and I have supplied it to the market. Now because of the huge demand, I'm having a demand ratio or a demand for producing 10,000 components. Okay, now in the meantime what will be happen? If one product is completely successful in the market, there will be having lot of alternatives in the market. Some other company will start producing the same model with adding some more thing. This is called as a c. Now if the same product is also entering into market, then what will be happened? So you have produced 1,000 number of components by February. Okay, by end of April, for you to produce 10,000 components, it needs 3 months. So you are going to produce the 10,000 components in the month of May. But suddenly, all of a sudden, there is a new product, C product, that is launched with the same specifications in the month of April. Now what will be happen?
So the competition of your product will increase.
Now in the May you have started distributing your products to the market. All of a sudden some other product is entered into the market in the May. Same component, same specifications by varying something, and D product is also entered. Now there will be having a huge competition. This is nothing but a speed of market. So if you are producing with a, I mean the same product continuously for a 2 months, 3 months, or for a year, what will be happened? So you are producing same b without any specific same specifications continuously till December. So till December you will be having a huge demand. After that, so if you are going to produce same number of components, then what will be happen? At the same time, the C and D are increasing their variants. They are increasing their versions. They are upgrading their features. Then they are going to launch it continuously. Then what will be happen to this B product? Will it sustain in the market, or the
So
demand will be reduced?
the market will be diluted and the demand for B will decrease.
Demand will be decreased because of the same specifications, all those things. Which means what will be happen? If at all you want to sustain in the market, if at all you want to maintain in the market, then you need to maintain the speed. That is nothing but there is already two new products in the market, that is C and D. So if at all you want to sustain, if at all you want to sustain for the next year, so you want to produce a phone that is a B1 model, which is completely newer, which is completely different from this B as well as C as well as D, then only your product will sustain, right? This is called as a speed of market, which means the industry need to work with respect to the speed. So with the market demand, with the varying in the demand in the market, how exactly the parts will be altered, how exactly the various demands will be coming into existence. That is speed of market. With which what will be happening? Industry will definitely try to change. So initially my plant is a medium scale industry, which means it is having only 50 missions with me. With the 50 missions, I have worked for 6 months. Now I have produced this 1000 missions. Okay, this 1000 phones, and I have distributed to the market at February, in the month of February. Now I have a demand of 10,000. Now if at all I want to produce this 10,000, so it will definitely need 1 year for me. 1 year if I use the same facility, but I want to produce in 3 months. Now, what I need to do? In 3 months, I need to produce 10,000 components. So, do I need to change my industry, or do I need to upgrade my industry or not? Because of this.
Yes, sir.
So that is what. So based upon the speed, based upon the demand, automatically my industry will try to change, tend to change, whether it's from a small to large or a large to medium or medium to again large. It will be like that based upon the speed of the market. Now same thing. So if your demand is continuously reducing, this is the first year, second year, and third year. In third year, you have launched B4 product, and hardly there are only 400 pieces that were sold, and you have produced 10,000 number of components by estimating the demand. Now what will be happened? Now you will be producing 10,000 components, and this is the B4 part you have prepared, and there are only 400 parts which are sold in the market. And now your plant is having a large scale manufacturing firm. Now the next version, if at all you want to use the B5, so whether you produce 10,000 components or you produce a limited components now,
Limited number of
limited
components.
number of components. For the limited number of components, you will you use this complete facility?
No, sir.
What will be happen if you use the complete facility? Then they will be having a lot of things, resources that will be needed for running this plant. Again, there will be a loss for this. So at the time, what will be happen? Again, you will be changing to some other model, or you will be using a part of this industry, which means only for a process you are going to use. So this is how exactly the speed of market depends, the industry changes. Clear? Next one is
Yes, sir.
multi product lines. Now what is this multi product lines? Now you tell me what exactly is this multi product lines.
So at a time we are producing multiple products, so we should have different product line for that.
Yes. See, there is, for every industry or manufacturing firm, there will be having some set of R&D. Okay, if the company has produced, sorry, if the company has produced B1 in the market, so before producing it, I mean before dispatching it, the company will already start working on B2. So while start,
B2.
yes, while start working on it again, there will be adding some more modification and try to launch B3. Maybe they will going to launch this B3 after an year. But what will be happen? They are start working on it. If they won't work on this B3, what will be happen? In future it is difficult for them to sustain in the market. So by considering all these things, while producing B1 itself, they are producing the B1. In the producing time, they will be working on the concepts of B2, or they are start to searching for the raw material. So while working on this raw material, they are working, some teams that are working with the concepts of B3, which means how exactly it is going to depend. So whether it is a circular, or do I need to use some oval shape, or a circular phone with some handle, or some circular phone with a selfie camera up and down, like this, they are going to work on some newer concepts, or circular foldable phone, like they are going to work on multiple product lines, multiple different scenarios. Otherwise what will be happened, if this product is coming into the market, it was entered, there is having a complete huge demand, or there is having completely altered demand is altered. No, because of which the plant is never going to fail or never going to stop. They are going to work continuously with some improvements. At the same time, let us take an example of Samsung. Samsung is producing some sort of mobile phones. It is not the only thing they are producing. At the same time, they are producing some other alternative lines, like they will be producing some TVs, they will be producing some other electronic appliances. These are called as a product lines. So they are working on some multiple concepts, and one product is working with the phone, one team is working with this one team is product with some other electronic goods. At the same time, one team is product with itself only with the product phone upgradation. Like this is called as a multi-product lines. If at all you want to sustain the market, if at all you want to maintain the market demand or ratio, then you need to maintain multi-product lines. This is one of the key thing. So if you are having this much of thought in your mind, then automatically your industry will try to change. So initially you started with the B1. So after working with B1, you will be having some sort of ideas with B2 as well as B3. for which you are going to implement a team. You are going to, I mean, recruit a team for B2. At the same time, you are going to recruit a team for B3. At the same time, you are going to recruit some other appliance like a TV for a TV appliances. Because of this, what will be happen? Your industry length will be increasing and your industry going to change continuously. This is one of the key aspect. Now this one, growing demand and increased variance. Now what is this one? Now you explain me what exactly is this. These two terms are growing demand as well as increased variance.
Suppose there is a product and its demand is increasing rapidly. At the same time, it means upgradation is also done. So for that, we have to change our industry.
Okay, I will give you an example. I hope you all know this Charisma vehicle, right? Two wheeler. Initially, they have launched this R edition. Hope you have seen it.
Yes, sir.
Now, are they launching the same product?
नो सर, मतलब if demand होगी तो उसका अल्फा बीटा गामा करके different versions निकाल सकते हैं वो.
One more thing then. If they are producing the same Charisma R vehicle, the model which they have produced in 2012 or 2014, if they are going to launch the same product in the market, now the demand will be this much when compared to the remaining Charismas. But still they are not producing this vehicle. Why? Or a four wheeler, there is a Honda Civic car is there. The Honda Civic is having a huge competition in the market, huge demand in the market, but still they have stopped the production for that particular model, for the particular 2010 or 12 model. Now have defined some modifications or upgradations and they have launched it in the market, but still the newer model is not at all even matching the this demand. Now this is having this much of demand. Now why they are not going to produce the same model? Why? Still they will be having that much of demand. Why they are not producing the same
Because
model?
So old model
because
parts
at
are not
some point
available.
of time, means
Old model
it
part
will
not
be
available.
common with everyone. And
Hmm. Any other things?
सर, क्योंकि उनकी जो डिमांड ओरिजिनल प्रोडक्ट की जो डिमांड है वो अगर रहेगी पहले से, तो उनका मार्केट में नाम रहेगा एक तरीके से, तो वो उसी उसी पे लोग सोचेंगे कि ये प्रोडक्ट नहीं निकल रहा है, नहीं निकल रहा है, तो वो सोचेंगे कि इस नए प्रोडक्ट में कहीं वो पुराने फीचर्स ना हो, तो उस चक्कर में वो जाके वो नया प्रोडक्ट लेंगे उसका.
Yes.
वो अपनी खुद की ब्रांड वैल्यू की डिमांड बनाए रखना चाहते हैं. वो
Perfect.
सिर्फ प्रोडक्ट के ऊपर नहीं जाना चाहते हैं, वो खुद की ब्रांड वैल्यू देखना चाहते हैं.
Yes. That is the answer. If they want to sustain in the market, their brand should be with the customers. Okay, the value of the like the Charisma R, Civic Honda vehicle, iPhone 5s, I hope so, that is one of the key variant for this iPhone. Samsung some Edge phone, Samsung 8 or I hope so, I forgot its number. Samsung Edge, there is a 8 or a Edge Plus, there is one of the phone. Nokia at that time 5233 or some Nokia sort of phones. Like all these are the brand, these are some of the benchmarks for this complete brands. Why? Because they have sustained the market, they have created the market, they have first time they have ruled the market. Now if they produce the if they say if the vehicle, if the Charisma R is going to produce continuously till now, now what will be happen? Even in 2022 also, if they are going to produce the same Charisma R vehicle, will anyone going to purchase that?
No, sir,
No,
because
sir.
it's outdated.
Yes. No, it's outdated. At the same time, there will be having a lot of competition that will be in the market, because of which what will be happen? The unnecessarily the demand, I mean the brand which they have created, the market they have created, that will be going to fail in the market. They want to maintain that. They want to maintain that rights. They want to maintain that sort of enthusiasm in the customers. That is why they haven't produced this thing. And in the terms, they will be going to produce some other things like this Charisma new vehicles, like the daily editions, like the same time Civic newer bodies, like different alternatives they are going to produce. So because of this, what will be happen? The customer will going to purchase this one by assuming that the Charisma R is that much of having value. So now what will be happening? These vehicle will having some more interesting things in it, or some more interesting factors involved in it. Like they will be assuming this thing and they are going to purchase this one by considering that brand value. This is what exactly happened with this one. So by increasing the demand, by increasing the growing demand, sometimes industry will going to stop the product, sometimes the industry will going to continuously produce the product. If they continuously produce the product, what will be happen? Automatically at some point of time the demand will be paused, the demand will be started reducing. At that point of time they are going to increase their variants, they are going to increase their number of components or the number of versions. That is what exactly growing demand and variance, because of which this industry will also try to change, this value is also going to change. Next one is unpredictability and varying demand. These both points are almost similar, but they will be having some difference in it. Unpredictability and varying demand, what exactly is this? Same thing as we discussed. If the company, if the Charisma Honda vehicle is going to produce this R vehicle continuously, even in the 2022, what will be happen? Because of this demand, automatically my production is going to halt, and because of this, I am going to reduce the price and I'm going to sold in the market. Because of which, complete demand will be altered. And unpredictability. Sometimes what will be happen? I have launched some 10,000 number of products in the market. Out of which, what will be happen? Because of some alternative product or because of some cost increase in the market, so instantly some other company which is going to produce the same component, that will be getting a huge demand because of the price involved in it, and this was failed. Unpredictability in the market, we don't know what will be happen in the market in tomorrow or day after tomorrow. If they are going to launch a mobile, so for some 40,000 with all the features involved in it, instantly in the next week some other company is launching the same specifications by adding some more things involved in it, by adding some eye catchy designs, and they are launching the product for 20,000. Now what will be happen to this one? Those who are working, those who are worrying for the brand, they will go for this one. Those who are worrying for the, those who will be having considered the money factor, then they are going to purchase this one. But majority will going to purchase this one. Because of this, what will be happen? This product will be increasing this one, and the demand for this product will going to reduce. This is what exactly happened. That is called as unpredictability and varying demand. We don't know what exactly happened in the market. Maybe this product is launching very soon, maybe in the next week they are going to launch. Because of which, what will be happen? Some specifications got released, and alternatively some other company has launched the product on the same day with the reduced price. That is also unpredictability. These are the things that will make the industry change. Okay, next one is increasing cost. Now this one, how this will impact this one. Hmm?
So if the cost of the product, like to manufacture the product, if the price of electricity and the price of operating the machines and the price of labor will increase, then automatically the product's prices also increase.
Okay, fine. There is one phone. Let us talk about this OnePlus. Initially, they have launched a phone. Initially they have launched with some 40K. This is the base variant, or this is the standard price for this OnePlus phones. So they have given this price range up to some OnePlus 8 or OnePlus 6, up to this extent. After that, they have what happened? They have started increasing its price. The initial price will be having some 50K now, but still there is a huge demand for this one. After that, this is for 7, this is for 8 also, there will be having one plus. Now they have launched some more things that are somewhat 80K. Now because of which, what will be happen? Maybe it is one plus 10 or one plus 9, I hope, I don't know exact number. It is somewhat 75 to 80K. So will they meet the demand? Will they meet this demand here? See, OnePlus 6 is 40K. They are giving high-end specifications in this one. Even in OnePlus 9 also, they are giving high-end specifications, but the cost is having some 80K, which is double of this one. Those customers who have bought these things will able to buy this one now.
No, sir.
No, sir.
But what will be happen if they cut the price and they have given it to 40K? What will happen to the market, and what will happen to the industry?
So they will suffer a huge loss, sir.
Why? Because they adopted so many n number of things. They were added so many things involved in it for this OnePlus 9, like sensors or everything they have involved in it. So because of which the price is raised to 80K. But they have, if they use this 40K, then there will be a huge loss for the industry. To sustain in the market, to sustain the brand, instantly the OnePlus has launched some product. I hope you know this one. Nord with some 25K. Because of which what happened?
So the demand for Node increased.
Because of this, again, the market which they have lost here, they have tried to regain this by using this one. So what will be happen? Till now the OnePlus is having some respect in the market, like it is a brand new phone, it is having some costlier phone which is more than 40K or 50K, but suddenly they have launched this Nord phone for 25K and it will be like 30. So what will be happening now? It is in the mid-range phone also. Now those who are purchasing, those who want to utilize this OnePlus brand value, then they are going to purchase this also. Because of this, what will be happen? The market for this, see, they have launched some 10,000 products for this one, but luckily unluckily only 5,000 parts were sold. Because of which what happened? The market was fluctuated here. So because of the market fluctuations, those who want this brand value, they have purchased it. Those who are worrying for the money, they are not purchased this one for this one. But what happened here? They have entered into the market again. Because of which what will be happened? Again the market is increased because of this price range. At the same time the demand, so the mid-range demand, because of the mid-range demand, because of the mid-range cost, some other demand is also increased in this perspective. So till now they have worked for only customers who are more than this one. I mean more, they are going to export more than 40,000, but they are in this market also. This is called as an increase in cost. Sometimes what will be happen? Increase in cost will decrease the demand. Alternatively, they should have some idea to sustain in the market. If they are not sustaining the market, if they are not launching this Nord, again they will be launching some OnePlus 10 with some 1 lakh cost. So what will be happen to the company now? In this previous case, out of 10,000 parts, only 5,000 parts sold. Now again they have launched some 10,000 parts here. How many parts will supposed to be sold here? At least I hope 5,000 parts will also be not sold at this condition, right?
Yes,
Yes,
sir.
sir.
The brand value will decrease.
So automatically what will be happen? The brand will be reduced, the value will be decreased. So instantly after OnePlus 10, they are forced to launch these things. They are forced to launch some OnePlus or some OnePlus new things that will be again around some 40K, so that they want to sustain in the market. This is what will happen. Because of the increase in cost, because of the increase in demand, if the company is going to increase the cost, we sometimes what will be happened? Because of increase in variance, the demand will also be increased. Sometimes what will be happen? The demand will also be reduced. So if at all we are talking about iPhone condition, Apple condition, what will be happen? Every year they are going to launch the product, every year they will be having that much of demand. Even the phone is having 2 lakhs or 1.75 or 1.4, whatever it may be, the demand will be that much high. Why? Because there are certain range of persons, the certain range of customers, they are going to purchase it. Based upon that, they are going to produce the model. Even though if they produce 10,000 components all over world, the 10,000 components will be sold, definitely sold, even though if it is a 2 lakh. Why? Because the brand value. So what will happen if the iPhone is launching again a new phone that is having some 30K? Now at this condition, what will be happened? If the iPhone is launching 30K with some benchmark specifications, again at the same time this is called as a one phone iPhone 15. At the same time they are launching one phone iPhone 16 with again 2 lakhs. Now what will be happen to this 2 lakhs phone? Will they meet the demand? Will they meet this demand, 2 lakhs demand?
No, sir.
There will be having demand fluctuations. Why? Because instantly they have reduced this one, so the company, the market will be raised. Instantly they have again releasing some phone with some 2 lakhs of cost. Because of this increase in variance, because of this sudden fluctuations, market will also be reduced. So this cost will always plays a key role in the market, in the industry. So if a product is increasing its cost, then automatically there should be having some alternative ideas to reduce the market price and to launch the same product. Otherwise, it is difficult for them to sustain in the market, with which the industry will tend to change. Okay. Next, automation in all aspects. So if the demand is more, like in iPhone cases, like this OnePlus cases, so every year there will be having a demand of 10,000 components. If there is a 10,000 components of demand is there, at this condition, what will be happen if I use a conventional machine? Will I able to get the production?
No, sir.
So if the production is continuous, if the production is in large scale, then at that areas I need to adopt some automations as well as different technologies for which I am going to increase my production rate. Now initially it will take 6 months for me to produce 10,000 of components. Now if at all I am using some or set of automations, PLC, some set of robotizations, newer concepts, Industry 4.0, and I have achieved this 10,000 components in 5 months. Now it's an achievement, right? So now I am going to launch the product more than earlier, more than expected. That is one of the things that will change the industry. Finally, robotization, both are same. So if at all I'm utilizing these two things, what will be happen? My rate of production will be increased. Because of the rate of production involved, I'm going to produce more number of components in the market. This is one area. Another area is reduction. If at all I'm going to use automation as well as robotization as different components in industry, so there will be having a huge investment in this. Maybe there will be having 10 crores of investment for the robotization as well as 10 crores investments for this automation. Together it is costing some 20 crores. Now if there is a capital investment of 20 crores is there, now what I need to do to get this back, to get the profit back? I have invested 20 crores in the industry. Now what should be in my mind? I want to regain this one. I want to get the profit from the market, the 20 crores. So that what will be happen? I will increase the cost of the product. Cost increased. Because of which what will be happen? If there is a brand value in it, I will get this one. So if there is a no any brand value, what will be happen? Automatically my cost, my demand will be reduced. So because of the reduction in demand, automatically again all these things will be affected. Clear? On all these aspects, the industry will try to change from a small to medium, medium to large. At the same time, large to again medium. So these are the different things that will make the industry change. Some of the things for this industry changes. Exception of a company, expectations of a company. That is, first is a time delivery, more efficient, content improvement with low cost and high efficiency. Now, if an industry try to change on these areas, the industry will try to change. First is time delivery. Now, what is this time delivery? What is this concept of time delivery? Any idea?
To meet the demand on means particular time, given time.
Okay. See, I'm utilizing. This is my plant where I am producing the cellular phones, mobile phones, circular phones. This is my circular phone. I have prepared some n number of components. There are every process involved in it. There is one more thing that is I'm procuring from outside. That is nothing but a screen guard or maybe some sort of things. Let us assume screen guard. So now this model will be finalized only after adding this screen guard to the phone. Then only it will be sent to the packing section. Now this is the thing. Now I am producing 10,000 components for every 5 months. So I am giving same thing to the procurer, I mean some other third client, to the client, stating that I am in a need of 10,000 I mean cell phone cases, circular cases. So you have to produce on or before. It is having 5 months of time. So I am giving the time as a 4 months of time. Now, if he is given the parts on or before 4 months, then it is acceptable. That is time delivery. If it is delayed, maybe it is delayed for 15 days or maybe it is delayed for 5 months exactly. So it was 5 months. It is also acceptable. Why? Because the maximum time is 5 months. Now, if it is more than that, if it is 6 months, now what will happen? Now the time taken for producing I mean the mobile cases for the third party client is having 6 months, but the given time is 4 months. Now what will be happen to this industry, X industry?
Sir, loss.
There will be having loss. Anyhow, they will collect these 10,000 parts. There will be having a 1 month delay. They will produce and they will sustain in the market. They will enter the market after a month. But what will be happen? Will they give the second project to the same company? they
No, sir.
they won't give the market, they won't give the second project, or they won't give the simultaneous things to the next things. This is what exactly time delivery will always plays a key role. Same thing. So if you have purchased a phone, it is out of stock and the company asked you to pay money and they want to deliver it by after 3 days or 4 days. Okay, so you have paid some 80,000 or 90,000 for some OnePlus 10 phone or OnePlus 20 phone. So you have paid the amount, and based upon the condition they have given is you will be getting your phone after 5 days. This is the maximum thing they have given. After 5 days you will be getting your phone. There is a 10 days, and even 11th day you also not receiving the phone. Then what will be happened? Maybe in the 12th day you have received the product. So will you support, I mean will you give recommendation to this phone to your friends or to some others? Do you
No, sir. No, sir.
why? Because so again there is this condition. So if at all you want a customized phone, you can pay the X amount and you will be getting the product on so X and Y date. So you have purchased this one, you have purchased on 3rd and they have given the date as some 8th, and finally you have received the product on 25th. So in this case, so will you recommend this product to some other person? Definitely you are not going to recommend. Why? Because you don't know when your product is going to dispatch. Because of this one, time delivery will always plays a key role in the industry changes. More efficient content improvements with low cost and high efficiency, as said. So if you are having multi different product lines, then automatically the product will be efficient. Improvements with the continuous improvements with low cost and high efficiency will also change the industry. These are the things that will be used in an industry that is called as a Kaizen. Hope you have heard this name. KIZEN. Kaizen is nothing but simple improvements, simple innovations, or simple improvements which will tend to increase the production, the rate of production. That is called as a Kaizen. With these Kaizen things, how exactly I am going to improve my plant, how exactly my plant will be expected in near future. All these things will be expectations of a company. And regarding product optimization, increase profitability, throughput, content planning with respect to time, energy efficient, and process optimizations. If at all your industry want to change, then regarding the product, you need to follow these things like profitability. For end of the day, every industry works with a profitability. So if you are utilizing all these things automatically, the increase in the demand will be there. So if there is an increase in demand, automatically the profitability is also increased. So if there is a large number of increase in profitability, automatically the throughput will also be increased. Why? Because so if you are producing 10,000 components, then the throughput of the process is 10,000. If the demand is more, demand is asking me to produce 50,000 of components, then the throughput is 50,000. So because of the increase in demand, automatically the throughput will also be increased. Content planning with respect to time. Now the demand is 50,000. So now the demand is more. I have prepared a plan for 10,000. Now can I run the same plan for this model? What will be happen? This model is designed for 10,000 components, which means this plant is validated for only 10,000 components. Now because of the sudden increase in demand, there is a 50,000 parts that will need to produce. So what will be happen if I give the same thing to this model?
So it will break.
It will going to fail at some condition, at the given condition, at the noted condition. So even in the middle of the, if the some after 10,000 components, the part is going to fail, the process is going to fail at multiple stations. Now at the time what will be happen, there will be having a use loss. Why? Because there will be having some parts that are already in processing, there will be having some parts that are going to process, and there are some parts that are waiting for the process to be done. So these are the different losses that need to complete to occur. At the same time, they are going to reinvent this model, complete model, and they are going to run it. So with which what will be happen, they are not going to meet this 50,000 demand in the given time. So whether the demand is 3 months, in 3 months I am going to produce 50,000 components. If the same model I am going to use, then automatically this model is going to fail, and I am not going to meet this demand, 3 months demand. Maybe after going, I am going to produce the demand after 4 months or 5 months. Because of the time delay, what will be happen? My 50,000 will be reduced to some 40,000 or maybe 30,000 also, because of the market variance. That is content planning. So if at all I'm going to work with something, if at all there is a demand increase in that, so I need to have some idea. So what will be having, if there is a 10,000, then this model is filed. If there is a sudden increase in demand, if there is a demand for 20,000, then what will be the alternative model for this? I need to have some sort of ideas, some sort of alternative model, so that whenever there is a demand comes, whenever there is a demand rises, automatically I need to use this type of model to run that one. That is content planning with respect to time. Like in the yesterday session, I hope I explained you energy efficiency. If the application is demanding me to use conventional machining, at the same time I am utilizing some CNC machine for producing more number of components, at this condition what will be happened? Then I need to consider this energy also. If at all I am producing 50 number of thousand of components, then automatically the power consumption is also that much of high. So I need to check on these aspects also, whether it may be a conventional, whether it may be a CNC, whether I need a manual, human interaction, or do I need to use a conveyor between a smaller stations? Like all these energy efficient things I need to consider. Process optimization, same thing. So if there is a big increase in demand, so automatically how I need to adapt to my process. So do I need to increase the model? If there is a lower in demand, if there is a decrease in demand, so how I need to optimize the process to withstand with the demand? Those are all called as the process optimization parts. Clear?
Yes, sir.
Okay, this we
Yes,
have
sir.
defined in the previous session. So plant simulation definitions. Now this is one of the thing, important thing. Why? Till now we have discussed where we need to use the simulation, or what are the different areas for which I am going to utilize the simulation. Here, why? What is the need of using the simulation? Why performing product and logistics simulations? Now, what is the need of doing this simulation? I'm asking you a simple question. I have explained you all the things till now, like the simulation capability, simulation usages, procedure of simulation, everything. Now, what is the necessity? Why am I supposed to do the simulation? Hmm?
So because of the unpredictability of certain factors in the market, you need to have a clear idea of how the production of your product will how the industry that you will work in works, as well as like how you produce the product, how much it is going to cost, and how much your profitability will be. So to do that, you need to have a clear mindset, and for that you need simulation
Okay. So
So
will
for profit, we use simulation
okay. So if I
to
at
make
all
profit.
okay, I'm giving a condition here. I'm not having any simulation software with me. I'm not utilizing the simulation software. Now I have produced 10,000 components in the market. Okay, with some manual principle, I mean, with some physical layout creation, physical modeling, everything I have created, and the demand is the 10,000 parts I have produced, and that was completely increased in the market. Because of the increase in market, there will be having a demand of 50,000. Now, if I'm not having a simulation with me, how can I supposed to maintain these 50,000 parts with me in the plant? How can I supposed to do that? Will it be manageable, or will it is difficult for me to produce
No, sir, it
50,000?
will not be manageable.
Why?
It
Because
will be very difficult.
it is very difficult. The plant model which I have defined, which in actual I have defined, which means first mission, second mission, third mission. After that, there is a fourth mission, fifth mission, sixth mission, and 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and finally there is an inspection, a package section here. There is a package, and this is the in and out package. After the package is done, loading and unloading will be happened. Here it is input: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. If these are my mission characteristic mission numbers, this is input coming here. So this model is working perfectly for the plant, for the physical plant. They haven't utilized any sort of simulations or any type of layouts directly. By considering some experienced person's views, they have placed the missions in these different areas, and they have run this one. This is one process. This is one process. All are individual process. Okay, everything is an individual process. And finally this is the section. Now for the 10,000 it was running perfectly. Now what will be happen if it is a 50,000? Will they are going to manage that?
No, no, sir, the plant will fail.
The plant will fail. On what basis it will going to fail? See, it is not going to fail on production. Why? Because these missions are capable of producing 1 lakh, maybe 10, I mean 10 lakhs or 20 lakhs of components. Even though there is having a smaller error, I mean there is having 5 hours or 6 hours of failure, but these missions are going to produce 50,000 components or 60,000 components by end of 6 months or 7 months, whatever the given time. But where exactly this will going to fail?
So cost and time.
Now, one
Some
important thing.
management of the product.
Yes, one important thing. Management of the product is a overview, but in detail there is one important thing in industry. That is one of the part which we are using the simulation. That is called as this one: logistics. Logistics is nothing but material movement between the stations. Here, how many components? 50,000 of components, which means continuous input is there. Which means for every 1 hour, there will be having some 60 parts. Okay. So which means after 1 hour, this third machine is having 60 parts with it. Now these 60 parts, let us assume the part is having some dimensions like 20 centimeters by 10 centimeters by 5 centimeters of some bar, some rectangle, some polythene or PVC. Now what will be happened? There are 60 components here. How the 60 components will be traveling from this direction to, I mean, this area to this second phase? After this, okay, once done. So again, there will be 60 components. From these 60 components, it will need to move to this location. How it will be happened? After that, it will be coming to where exactly? Okay, this station. Again, it will be coming to this station. This material movement, this is called as a logistics, internal logistics. Because of this material movement, it is taking lot of time. So for an hour, I mean for every hour, it will producing 60 parts in the process one. And for the movement from process one, from third mission to fourth mission, it is taking half an hour to reach here, 30 minutes to reach here. Again, from this location to this location, again 30 minutes. Why? Because loading the material on a truck, on a forklift or something, and again it is coming this station and it is unloading here, 30 minutes. So for every material station, there will be having 30 minutes of delay. So because of which, what will be happen? There will be having loss, I mean huge loss on the material handling itself, logistics itself. In this perspective, in the logistics perspective, the company is going to fail. Okay, now with the plan, if at all they will be having a plant simulation, now they will need to finalize. So if at all they want to reduce this material handling movement and they want to utilize the complete space, this is the space they will be having. So if at all they want to use the same space, instead of 1 2 3, after that they will be placing 4 5 6 here, so that all the emissions are in a row. Step by step process will be happened. There is no any material handling will be done. After that, instantly 7 8 9 can be placed. After that, there will be having 9 10. So if there is having systematic procedure, maybe if this 13 14 15 are hazardous in nature and they are going to kept some place, no problem. At this particular condition, they are going to place at the corner, but at this condition only they are going to use the logistic service. After that, they are going to again continue the process. This is how exactly we are going to create the model. This is why we are exactly using this simulation, not only for the production. At the same time, we are going to check the logistics also. So with respect to missions, how exactly it is producing, so what is the failure time, what is the delay time, what is the bottleneck, that also we can be monitored. At the same time, how the material is moving between stations or among stations or in the plant, that is also be monitored by using this simulation. These are the two essential things in this with this software. One is for the production and second one is the logistics, which is nothing but material movement between stations. Now, this simulation will be used for the basic two things, and apart from this, we are going to use these things also. Validate plans. I hope I explained you. What is validation? I have created a
Checking
layout.
the feasibility of the product, the line.
Okay. Validating nothing but testing at maximum conditions. So that is what exactly validating is. Validating plans is nothing but I have created a plan. Now I want to check at what condition this plan is going to fail. At each and every interval, which means at one day how the behavior will be. After 30 days, what will be the behavior? At 60 days, what will be the behavior? At regular intervals, we can check the plant. At the same time, what will be the maximum extent at the plant that is going to run, or at the maximum where the maximum extent the plant is going to fail. That can be identified with this validate plans. That is where one of the key aspect where we are using this simulation. And after that, optimize manufacturing cost. This is also one of the element. So I have prepared a layout. In that, there will be having some set of missions, some n number of missions. So if at all n number of missions will be placed in the layout 1, what will be the cost? So if at all I placed in the 2, what will be the cost? If at all I placed in the 3, so what will be the cost? Like I need to check the different scenarios on. So what exactly the cost will be if at all I'm using 1 2 3. So what will be the manufacturing cost if it is a 1? So what will be the total number of parts that is involved in the plant if at all I'm using the plant number, I mean model number 2. If at all I'm using layout number 3, what will be the total manufacturing cost? That can also be monitored. At the same time, if at all the second model is a perfect one, at the same time I want to reduce that one, reduce the cost of that one, I can do that optimization part for that one, to decrease the space between the stations, to remove the unwanted energy resources, to remove to improvise some missions by using the conventional missions, or to reduce the number of human involved in it, to reduce the reputations or I mean reputed things by involving some robot over there. Like that, I am going to optimize this manufacturing cost. Third one is perform what if scenarios. One of the key thing, so this simulation will be completely based on this word itself, what if condition. Okay, so if at all I create the plan, what if I have changed this mission, what if I have created another model, what if I have removed this mission, what if I have used this conveyor, what if happened, so if at all I remove this human, this complete plant simulation will works with this scenario only, what if scenarios. What will happen if I remove this one, what will happen if I modify this one, what will happen if I try to optimize this one. Like this complete plant simulation will work with this what if scenarios only. Finally, one of the important thing is predict requirements, energy requirements. I have created three different layouts here. So what will be the cost of this first layout and what is the energy requirement? What is the second cost? What will be its energy utilization? What is the third layout cost and how much energy it is utilizing? If at all I want to optimize the energy resources, how can I suppose to do that? What are the different forms of energy resources? So if at all some missions are not in utilizing up to its mark, but they are going to need in the need in the process, how exactly I am going to optimize it? Do I need to switch off the mission or do I need any alternative models? Like I need to get some different scenarios for this energy requirements also. These are the some of the areas why we are using this simulation. This simulation will basically use it for the preparing the production, I mean checking the production as well as logistics for a simulation, for a plant, for a model. In the production, we'll be validating the models, optimizing what if scenarios, predict energy requirements, all those things involved in this prediction. When coming to logistics, we'll be having the material movement, how the material movement is happening between the stations, how the material movement will be happening between lines. Okay, all the things we can be checked in this logistics. These are the essential things why we are using simulation. Okay. This we have discussed in the previous day. So before starting a simulation, how to start a simulation? For starting a simulation, these are the essential things we need to collect before starting a simulation. In planning phase, what are the different things we need to consider? In manufacture planning, what are the things we need to consider? In project planning phase, what are the things we need to consider? All those things will be described in this startup simulation. And this is the one of the important thing again, features. By using the simulation, I mean by using the simulation software, what am I capable to do? What are the different things I am capable of doing? That can be discussed in this one. So with the simulation software, we can create process plant and its component, which means any type of plant, running plant, not actual any type of running plant we can create by using this software, and we can test the components, that is a process plant and all its components. We can create automation nothing but whenever there is a need of conveyor we can do that, whenever there is a need of some AGV, automated guided vehicle, we can do that, whenever there is a need of some automated like lifts or some sort of things, there will be having some lift, there will be having converter, turntable, all those things. So if there is a need of automated things, then we can create it in the software. So we can work with robotics also. So whenever there is a repetitive task here in the application, so instead of using a human for a repetitive task, for increasing the efficiency, I will be using a human, I mean using a robot for a material handling purpose. So from picking a part here and placing here, for picking a part here, placing here, or for picking a part from a mission and placing on an AGV for a material handling application. If there are two conveyors are there, so I'm going to pick a material from this conveyor, I'm going to place this conveyor, place on this conveyor. That can also be possible. Even I can give the strategy also. There is a robot here, and there is material coming from a single conveyor here, and there are three conveyors here. I can distribute the material. So on what basis I can distribute the material? On what condition I need to maintain the this one? How I need to maintain the order? So do I need to give 1 2 3 like this, or 1 2 3 like this, or do I need to give 1 2 like this and 3 to this one and 4 to this one? Like different applications we can perform with the help of robotics also in the plant simulation. We can work with ergonomics. Ergonomics is nothing but human involvement of human in the plant. So what is the need of human in the plant, how exactly human will be beneficial for an industry, so what are the roles and responsibilities of a human in a industry. So if there is an hazardous zone is there, which means if a CNC machine is there which is working with some 100 degrees or 200 degrees temperature, so no any human is going to enter into this hatched section. If there is an hatched section is there, so how we need to define that person, the human, to work here. So what are the precautionary measures that we need to follow? If there is a conveyor is there, overhead conveyor is there, so beneath that no any human need to enter. So this is a law, I mean this is a clause. If a human need to enter beneath that one, it is a mandatory task. So he need to enter to that area, and there is a mission here, and he need to operate that mission at this condition. How we need to assign the human? So what are the things we need to consider? If the human need to work only for 8 hours, with respect to shifts, then what are the shifts, how the shifts are not going to work? So if the human is having he need a break after 4 hours, for every 4 hours the human we need to assign some break, then how they will be reaching to the station, how they will be collecting the information? If the material handling between station to station is going to operate by a human, which means he need to pick a part from this station and need to give it to this station, then how this material handling with respect to human is happening? How much time it is involving? How much time is he working? At the same time, how much time he is sitting ideally at the station? That can also be monitored. All the human related things can also be worked with this with the plant simulation. We can create data sheets for human operations like I explained you. So if a human is involved in an operation, we can collect the complete data by using the charts. There are charts like this. In the charts it will be explaining if it is a green, 20% of green is nothing but 20% is working, and then there will be 30 percentage of waiting phase, then there will be 20 percentage of break time. Like we can define the human efficiency also, we can calculate the human data sheets also, like how much time is utilizing, how much time is not utilizing, all the things also we can be operated. We can work with automated things. Automation are completely, I mean, somewhat same, but automated things like AGVs, turntable, turn plate, these are all, whenever a part is coming here, automatically it will be programmed. So if there is an AGV is there, AGV is programmed to pick a part from one place to another place. If the capacity of AGV is nothing but it is like a vehicle, automatic guided vehicle, it will be having four wheels, and there will be having a yellow line that will be as a trace line. So this AGV will trace this line and it will go to some location, and we need to define the capacity. If the AGV is having only four parts of capacity, then once the fourth part is already placed here, so automatically AGV started moving from this location to some another location. These are working with the automated things. Next, we can work with fluid process. Till now, we have discussed about only solid parts like a part, watch, helmet. Like we have discussed these things. We can work with fluids also, which means if there is a milk industry is there. In the milk industry, what will be happen? There is a sort of milk is there. There is some sort of water is there. They are going to mix both at some criteria. Then we are going to work that area also. How we are going to use a pipelines, how we are going to use some walls over there, how we are going to operate some tanks, how we are going to operate some mixers. If it is a chocolate manufacturing company, then what will be happen? There will be a bigger tank will be there. In the tank there will be a hot chocolate will be poured and it will be entered into mixer. In that mixer there will be having this inlet, hot chocolate, I mean cocoa powder from one section, and there will be having milk from another section, there will be having sugar from one section, there will be having some other thing, some n number of components in this section, and once it was filled, automatically this will be mixed. So that mixer will also be visible. So once the mixer was done, then it will be dispatched to some other injection molding machine, where it will be dispatched to the trace where the chocolate will be collected. That can also be paused. So we can work with the fluids also in the plant simulation. At the same time, we can work with some advanced applications like if at all I am going to prepare a building. So till now we have worked with a layout industry. What we have assumed industry is a ground floor itself. Industry is completely ground floor. Now what will be happen if an industry, the industry is having three story, I mean three floors building. In the first floor there will be having some missions, in the second floor there will be having inspection, in the third floor there will be having some set of compositions, in the fourth floor there will be having again inspections. If there will be having multiple story, then how the human will be entering to each and every station, how the power resources, how the material movement is happening between stations. If the material need to enter into fourth stage, I mean fourth story or fourth floor, how the material is moving. If the material weight is more, I mean material weight is itself having some 10 kg, then how the human will do this operation? So I don't want to use human over there. Then what type of applications do I need to use? There will be having some lift applications. In that lift applications, how can I supposed to lift the particle from this area to this area? Or else I can use some spherical conveyors. What will be happen? These spherical conveyors will go to the fourth floor like this. So part will be reaching to the final, I mean to the floors. Generally these will be used for the height sections. It will be. So how the material will be inspected over there? After the inspection, how the material is coming to back to its original location? All the things we can be used in this plant simulation. Finally, we can create multiple data sheets for majority of the components. If there is a component involved in the plant simulation, for that there will be having a data sheet. If there is a conveyor we are using, for that conveyor also we can use some sort of data sheets, like how much time it is utilizing, how much, what will be the capacity of the conveyor, what is the maximum capacity, at what time the conveyor is on a peak load. So what are the different components, what will be the pitch that will be needing in the conveyor, what is, if there is a failure happened in the conveyor, so how much time it was failed. So like these are the different criteria we are going to collect. So if at all there is a component involved in the plant simulation, for that component we can directly use some data sheets to monitor its performance. Okay, these are the some of the features of plant simulation. Not only that, there will be having some more important things, some more factors, like we can create multiple data sheets. These are all completely for data sheets, which means charts. We can collect data sheets for workers, which means we have discussed in the previous session, I mean previous slide. If the human is involved, how much human work is performing. If there will be having 5 different workers, so we can compare all the 5 workers. So whether all they going, are they working perfectly or not. If some humans are utilized for material transportation, I mean material handling between stations, so how much time he is operating the mission, how much time he is picking the part, how much time he is traveling to some other I mean station which they have defined, how much time he is sitting ideally, like we have calculated the complete performance chart of the worker. At the same time, we can calculate performance charts for mission as well as operations. If there is a mission, like 5 missions, 1, 2, 3, 4, 5 missions, how much time the mission is waiting, how much time the mission is working perfectly, how much time the mission is having a blocking phase, how much time the mission is having a failure, how much time the mission is having a unplanned things also. Those things can be operated, I mean checked by using the charts. We can check the performance of conveyors. This I have explained you. If there is a conveyor, like different parameters that are involved in the conveyor, that can also be optimized, that can also be checked by using these data sheets. We can create performance of robots and its operations. If there is a robot is there, a robot is picking a part from this station and it is distributing to 3 stations. How this distribution is happening, how much time the robot is working, so how much time it will be picking a part, how much time the robot is having a part with it, how much time, maximum time. So for the station 1, how many parts it has produced, for station 2, how many parts produced, for station 3, how many parts it has produced. If there is an error or delay in this one, so what will be the delay, so how much time the robot is in a failure state, so at what conditions the robot is failed, for a, what will be the interval for the robot failure. All those things we can check by the process sheets of robot. We can check some performance charts for the process and about its output. We can check the process also. If there is a process like this, for this process I can directly check if this is a process, what will be happen by directly clicking this drain characteristics, drain charts. With the drain charts I can check what will be the throughput, what will be the throughput maximum conditions, at what time the throughput is dull. So all the things we can check by using these things. Next one is, it is possible to create performance of the mission status in the terms of occupancy. Yes, in the throughput also we can collecting by using some charts. Mission occupancy, how much mission occupancy is there. So if the mission part is coming here, so how much time the mission is having a part, how much time the mission is not having a part, how much time that mission is having a part in it and the mission is in a failed condition, that can also be monitored. It is possible to create the charts, throughputs of missions that we have discussed. We can prepare Sankey diagrams. Yesterday, I hope I have shown you, but again I explained you. There is a process. Okay. This is process A, and this is process B. Process A ends here, and process B ends here. The material is coming here, and here at the station, the material will be distinguished. Here there will be having some 1,000 components for every day. Here there will be having some 500 components. Now if I click the Sankey diagram, then what will be is, so there will be having a green line, thick green line. So why? Because there will be having 1,500 components traveling from this conveyor up to this. There will be having thick line. Now the line will be diluted here. So it is compared, I mean it is compared to less. If the length of this green line is 5 centimeters, here there will be having 3 centimeters of thick line, here there will be having 2 centimeters of green line, with which what we are going to observe, the material movement. So how exactly the material movement will be. So if the material is moving like this, then there will be having a thicker green line. Huge number of parts will be leaving. Here there will be having limited number of parts that will be entering. So there will be a green line that is representing in a thinner line. If there will be having one more line, it is having only 10 parts that will be coming here, 15, 10. Then it is having only single line here. So anyhow the parts will be going. That is why there will be having a green line, but it is a thinner when compared to these three. This is called as a Sankey diagram. These are used for the material flow detection. Any doubts?
No, sir.
Okay, fine. There is this. Next one is we can prepare statistical reports. Thank you. We can prepare statistical reports like data fit, roll days, distribution, ANOVA comparison. These are all completely somewhat advanced level of data sheets where we are going to calculate the data. I mean, if there is a prediction, if there is a future prediction is there, if there is a demand increase is there, if the because of increase in demand, how the data is fitting into this one. This model is prepared for 10,000. What will be happen if I run to 50,000? Where exactly it will going to fit? How the data will be, that is called as the data fit. Roll dice, distribution, what these are all advanced computation methods where which we are going to improvise the process. Okay, I will explain you these things when I show you the software. The next one is analysis tools like bottleneck analyzer, energy analyzer, experiment manager. Bottleneck analyzer is nothing but if there is a process. So this is a process. Uh, just a second. There is a process like this. The material is continuously coming here. Okay, and there is some more process that is adding here. Okay, from this machine there is a continuously 100 parts will be continuously coming here and this machine, and this is one input and this is another input. So two inputs will be entering into this machine, because of which what will be happening, there will be a bottleneck here, which means the parts will be clogged here. Why? So let us assume this processing time is only 1 minute. So for every 1 hour, I mean there is having one I here, for every minute there will be having a part here, for every minute there will be having part. So the part is coming here, so automatically it will be entering into this machine processing. In the meantime another part is coming here. At the same time this conveyor is also producing a part. So here there will be two parts that will be waiting. Again for next minute there will be having two more parts, for the next minute there will be having two more parts. This is what exactly happened. This is called as a bottleneck. We can directly check the complete process. Once we have defined the process directly by using this bottleneck analyzer, we can define what will be the mission statistics. If this, what will be the bottleneck analyzer for this mission, so how much time it is green running, how much time it is in blocking phase, how much time it is in ideal phase, that directly we can check by using this bottleneck analyzer. Like we will be having energy analyzers with which we can directly calculate the complete energy involved in this plant. This plant is having some 30 emissions. So together what will be the maximum, I mean what is the complete usage, we can directly describe by using this one, energy calculations. So what is the maximum usage, what will be the single emission usage, what will be the I mean usage of each and every emission at that time, perfect time. So if this machine was utilized for 3 hours, what will be the calculation? If the machine is utilized for 5 hours, in the process there will be having 30 missions. In the 30 missions, out of 30, 10 missions are utilizing for 3 hours, 10 missions are utilized for 2 hours, 10 missions are utilized for 1 hour. So because of this energy analyzer, I can get a value of what will be the maximum usage of this one. After that, so these 10 missions that are utilized for 3 hours, what is the maximum usage of this thing, and by with this process what is the usage, and in this process what will be the usage, that can also be defined in this energy utilizer. And there will be having experimental manager with which I am going to check. So what will be the alternative method? I have defined a plan like this. So what will be the alternative method, or what is the maximum condition which is going to fail? That can also I use to check by this experiment manager. Performing industrial operations, these are all the important, these are the some of the features of the plant simulation. Not only these things, there will be having huge number of things, huge number of features that are involved in the plant simulation, with which I am going to conduct what if scenarios of the plant, with which I am going to do the production as well as logistics simulations to improvise the plant efficiency. These are the things. Okay, and we have discussed this thing also. Tomorrow I will show you these things by using the software. I will show you, so what are the different things, how we are going to process plant, what is the missions, all these things tomorrow I will show it to you. Okay, anything you want to raise or any doubt so far?
No, sir.
Clear?
No, sir.
Everyone, so far clear? This is the third day of session, that is why
Yes, sir.
asking. If you are having
Yes,
any
sir.
doubts, what will be happen? This will be carry forward. Why? Because see, in my presentation also there will be having a previous slide involved in it. The day one session that will be going to come on the 8th day also. That is why I'm just asking you, if you are having any doubt, ask me in that slide itself, so that I will explain you maybe 10 times or 20 times. But carry forwarding a doubt is always and not a good thing. Okay. I hope it's clear. If you are having any
Yes.
doubt,
Yes, sir.
no worries. You can ping me anytime by stating the thing. Okay, fine. Chalo then, guys. Okay, have a great day. Bye.
Thank you, sir.
Thank
Thank
you.
you, sir.
Thank
Thank you,
you.
sir.
Thank you.
Thank you, sir.
Thank you.
Sir,
Yes.
sir, I have no doubts, but I have one, मतलब एक क्वेश्चन आया है ऐसे ही दिमाग में कि हम डिसीजन मेकिंग कैसे कर सकते हैं, जैसे फॉर एग्जांपल आई हैव अ इन्वेस्टमेंट ऑफ 10 crores एंड आई हैव कैपिटल ऑफ दैट, सो अब मैं मार्केट में एकदम नया हूँ, आई एम एकदम न्यू टू मार्केट, so I have two cases, like case one is that I can go like a premium product, like I am manufacturing Apple, these phones like Apple, or which are higher prices.
Okay.
Or either case two is like I can manufacture product like Micromax, so it comes sales and it's out of the market.
Okay.
So मतलब हम इसमें क्या करें कि हम वाइसली डिसीजन ले पाए,
That is depends upon the market survey.
हाउ मतलब
For that, so I mean, मैंने आपको
ओके
बोला डेटा कलेक्शन बोला स्टार्टिंग फर्स्ट स्टेप. सो मॉडल डिस्क्रिप्शन. सो बिफोर मॉडल डिस्क्रिप्शन हमको मार्केट सर्वे करना पड़ेगा. अगर आपने इंडस्ट्री स्टार्ट करना है, देन व्हाट आर द इंपॉर्टेंट थिंग्स यू नीड टू कंसिडर. हाउ इफ एट ऑल यू वांट टू launch a luxurious product, luxurious phone, then if at all I launch a luxurious product on the market, then what will be the competition? So do I sustain before this Apple? Like, you need to have some things. So if at all you want to launch the luxurious phone at some moderate price, then what is the competition for that? If at all you want to launch some 40K or 50K, then what will be the alternatives for this one? So at your features, like, you need to keep a survey on the market. That is what we call
ओके
as a digital marketing or market surveying. So in that market surveying, what will be happen, they will be having a huge response or lot of response you need to collect from the in and around world, so that you will collect a complete feedback. So whether this product you are going to launch will be definitely, I mean, you will need to launch, or do you need to any modifications for that, or do you need to change the plan itself. Like you said, either case one is correct or case two is correct in the present scenario. That will be depending upon the market scenario only, market conditions. That is what exactly in the daily news also they will going to say, the market condition is fluctuating. In this condition, what will be happen if you try to invest something on the market, then there will be having, because of the market fluctuations, your demand will also be varied. So you need to work on the market. So if at all you want to launch some cellular phone, for which you need to purchase lot of components from some other third party clients. Now what is the third party client behavior, that also you need to monitor, that also you need to start surveying. So if at all you want to go a mobile with a carbon fiber, then where exactly you are going to purchase a carbon fiber? For a normal individual, how much carbon fiber is purchased, that is also be, there is a limit. For an industry, what will be the limit of carbon usage? So what are the different companies that are going to use this carbon fiber for the manufacturing a phone? Like, you need to start a complete survey on this one, on different scenarios. So once we will be having a market survey, present day market survey, I mean, you are going to launch the product on 2023, then you need to start surveying on day one from today. But again, you need to start surveying on that day itself. On 2023, what will be the market? Maybe the market will be changing from today to 23. By collecting the information on 2022 and starting an industry at 2023, it will always be a riskier one. So how the market will be at that time you are going to start, that you need to expect also. Maybe sometimes you need to predict, maybe because of there is an increase in demand, maybe in 2023 there is a some more rise in the demand. Or maybe you can think like this also, maybe there is a lot number of competition in the market, the demand of the mobile phone is going to reduce in the next coming year. By considering this also, you need to plan accordingly. That is what exactly market surveying. Once the market survey was done, then they will be having this software. You can start working on this one.
Okay, sir. Thank you, sir.
Okay, thank you.